We are Team 7 from Dr. Benson's FSC 100 Intro to Engineering class. My name is Justin,
My name is Luis. My name is Brendan.
My name is Ben.
and today we are going to tell you our design proposal for the Waterwheel in order to create more power.
So we chose the Waterwheel because it was the most reliable. There's water sources in just about every region that we would market it to, and B, it's constant rate unlike solar and wind. Solar and wind, you're running a chance whether you would have enough power that day or not. And unlike water is a constant rate, so you're gonna get the same amount of energy every single day, no matter what. Um, we made a water wheel using balsa wood, plywood, a metal rod, and some bearings, and a generator to produce power. And so far, we are on budget, and hopefully, we will finish our project within the next week or two.
So, as everyone wants to know, how does one actually produce power with just our alternative resources? So, with our water mill, what we're doing, we are taking a rod, we're putting a gear through it, which is a 50-tooth gear. We are connecting that with a 20-tooth gear, which is connected to a motor generator. What the motor generator does is that when it spins, it will produce power. We learned that when we are able to get about 10 volts worth of power through the 50-tooth gear connected with the 20-tooth gear, we actually produce about 15 volts worth of energy. So what this means for us is that with just 1 volt, we are producing 1.5 volts in total. What this does for us is that when the wheel is going to be turning, connected with the gears, we will produce even more energy than what we are actually using.
Okay, so basically when it comes to our rod system, we wanted to find a good way to basically attach our wheel and our gear to a piece of metal or wood so that everything would spin nicely. Originally what we wanted to do was attach everything to a wooden rod and basically drill a hole into a piece of wood and then just stick it in there. But we decided that it wouldn't necessarily be safe as it would probably cause a lot of friction and it wouldn't necessarily stay in because it would just fall out. So what we did decide to do was to order a aluminum rod and basically attach it to the wheel. And basically when it comes to attaching it to the actual board, we did exactly what we did before and drilled a hole into the wood and basically stuck 3 bearings inside of there and basically secured it, and it spins very nicely and well. With that, we basically overcame all of our fears of having it completely just fall off and mess up. So with that, we found that it was best, and we were good from there.
Alright, so for the wheel, we chose to use plywood for the outside because it was the most malleable and the easiest to measure and get a circumference as well as sand down. And then the only mistake I feel like we did make with the wheel is that we did the inside before we did the outside, which caused us to have to repeatedly change the size of our inside panels because we didn't really know what the outside of the wheel size would be. And then as well as for the inside of the wheel, we chose 1/4 inch thick balsa wood, which we felt like would be the best because it was easy to cut. It wasn't easily warped by the water, obviously. This was one of the main reasons why we chose it. And then we made them about 8 inches long. So it was like an 8x4 piece of wood, and we put in 6 of them because we almost cut it up like a pizza. And then we just put the pieces on there so it would fit right as well as have like the normal water wheel-esque kind of look. And then when we were finished everything, we used regular wood glue to glue it all down first. and then we had to wait around 5-10 minutes for that to dry. And then after that was all done, then we used hot glue to kind of finish it all off, as well as the tape that will be used to help prevent water from getting into key spots.